Applications of inequalities can be solved using the following steps. Step 1. Write a system of inequalities to model the situation. Step 2. Label the axis and graph the system. Step 3. Find the shaded region and list the outcomes of your work. It is important to note that this will require a graphing utility like Desmos.com to complete the exercises. In example 1, Ava started a breakfast food truck and it sells small waffles, 2 scoops of batter, and large waffles, 4 scoops of batter. She knows she can get at most 200 scoops of batter out of her supply. So we're going to take that information, 2 scoops and 4 scoops will max out at 200 scoops of batter. So we're going to call S and L the number of small waffles and the number of large waffles. So 2 scoops per small and 4 scoops per large will give me less than or equal to 200 scoops of batter. Now let's look at the next bit of information. She charges $4 for the small waffles and $7 for the large waffles. So 4 for the small plus 7 times $7 for the large will generate greater than or equal to $360. If Ava wants to earn at least $360 during the breakfast rush, what system will allow this to happen? So here's the system, and you can see how I'm pulling that information from the given paragraph. And so now I need to convert this to a system I can easily substitute into, say, Desmos.com. So we would have 2x plus 4y is less than or equal to 200, and also 4x plus 7y is greater than or equal to 360. Notice that I'm using x as my smaller and y as my larger just because x comes before y. Try and find some way of keeping track of your variables and what they stand for. Now we're going to switch over to Desmos and we're going to graph this. So here we have 2x plus 4y is less than or equal to 200. Now I'm going to enter the second one, 4x plus 7y is greater than or equal to 360. And I'm going to change this one to, let's say, green. Now, I do want to point out here that since both of these are or equal to inequalities, they include the endpoints. On a line, it includes the line. It's not a dotted line, it's a solid line. So this overlap region here is where the person with the food truck, Ava, would generate $360 or more in income. So just keep that in mind. So I can click on these intersection points, these areas of interest, and I can see that these intersections are where I'm bounded. So now let's go back to the graph paper, and I'm going to quickly sketch this and then I'll come back to you. So here we have the 3 points that bound the area that is true or will provide what the system requires. And those points are 20, 40, 90, and 0, and 100 and 0. Let's look at example 2. Ben sold his photography at a booth at an art bazaar. Each small photo cost $4 and each large photo cost him $10. These is to manufacture them. He doesn't want to spend more than $300 on photos to display. So let's go ahead and highlight that information. $4 and $10 for small and large photos respectively, and he does not want to spend more than $300 prepping his booth. In addition to that, he knows that he wants to have more than 45 photos. So a combination of the small and the large would need to be greater than 45. So now we need to determine how to graph this. So once again, we'll go to Desmos and we'll graph this system. So here you can see that the intersections of the two graphs provide an overlap, and we always assume that this has to be bounded by x is greater than 0 and y is greater than 0, because otherwise it just doesn't make sense in real life. So it's always in this first quadrant of the coordinate, the Cartesian plane. So that being said, our solutions are bounded within these three coordinates: 25, 20, 45, 0, and 75, 0. So we'll go ahead and sketch that on a graph, and then we'll be done. So here, the bounds on my solution to the system of inequalities is 25, 20, 45, 0, and 75, 0. Now, what does this mean? This means that any combination of photographs that is within the shaded region will generate a inventory greater than 45 photographs, and the cost to set up his booth, Ben's booth, will be less than or equal to $300. So any coordinate point within these parameters will provide that situation. The extremes on this scenario would be if there were 25 small and 20 large, 45 small and 0 large, and 75 small and 0 large. All of those would still provide that same solution. Like, you would still stay within the parameters of what Ben wants. All right, that's all.